introduction and then Kulkeet. Sure. So, hello again. Good evening, everyone. Welcome you all to the Future Technologies session in the Web Summit on Future of Environment as part of the Future series, sponsored by platform sponsor RateGain. So, Future Technologies will be presenting innovative technology solutions from experts, institutions, and organizations across the globe on how do we make our future environment safe. Before we start off, let's play Kulgeet. Vaibhav,
Yes, sure.
Vishaka.
Vishaka, okay. Oh, Vishaka is singing, sorry, my bad.
मधुर मनोहर अतीव सुंदर ये सर्ववेद्या हे राजधानी राजधानी मधुर मनोहर अतीव सुंदर ये सर्ववेद्या हे राजधानी राजधानी ये तीनों लोकों से न्यारी काशी सुज्ञान धर्म और सत्य राशि बसी है गंगा के रम्य तट पर ये सर्ववेद्या की राजधानी राजधानी मधुर मनोहर अतीव सुंदर ये सर्ववेद्या की राजधानी राजधानी नई नहीं है ये ईट पत्थर है विश्वकर्मा का कार्य सुंदर रचे है विद्या के भव्य मंदिर ये सर्वश्रेष्ठी की राजधानी राजधानी मधुर मनोहर अतीव सुंदर ये सर्ववेद्या की राजधानी राजधानी मानवीय जी की देशभक्ति ये उनका साहस ये उनकी शक्ति प्रकट हुई है नवीन होकर ये कर्मवीरों की राजधानी राजधानी मधुर मनोहर अतीव सुंदर ये सर्ववेद्या की राजधानी राजधानी मधुर मनोहर अतीव सुंदर ये सर्ववेद्या की राजधानी राजधानी
Thanks, Vishaka. This rendition of Kulgeet felt divine. Thank you so much. Moving forward, future technology session is moderated by Mr. Shankar Ramurthy, 1982, chemical engineering IIT BHU alumnus with diploma in management studies. He is a water sector specialist who has spent 37 years in water sector around globe. He worked as business head, VP, GM for various companies across. Before we start off, I would like to wish Dan Jeevans, leader at Data Science Center of Excellence at Shell, UK, a belated happy birthday, sir. Over to you, Mr. Shankar.
Thank you, Kirti. Good evening, everyone. It's my pleasure to meet again for the evening session. Morning session was very exciting, and I promise that evening will be more exciting. And we got a very good feedback from various sections about the morning session that we had, which was very encouraging. Evening session, we are lined up an array of inventors, scientists, entrepreneurs, not only from India, from across the globe. To begin with, on the future tech sessions of the evening, first we have Professor Raghav Verma. He has achieved so much already in his field of application and research and publications. In a short, I will be able to, I'm trying to cover what he has achieved so far and introduce him. Professor Raghav Verma, he's did master's and PhD in physics from IIT Kanpur. He spent a year at Tata Institute of Fundamental Research as a visiting fellow. He spent 3 years at research associate at State University of New York, Stony Brook. He joined IIT Bombay as assistant professor, and he is also a scientific associate at Geneva, Switzerland. Professor Verma is an experimental nuclear and particle physicist and has more than 400 publications to his credit. The key subject that Professor Verma is going to present is on the future technology in wastewater applications. We all know that the wastewater application has evolved over decades from the conventional activated sludge process, the moving bed bioreactors, the sequential batch reactors, and then the membrane bioreactors. As we go along the evolution of wastewater applications, the product water became more pure and pure, and it occupied lesser and lesser footprints. Now what next? That's where Professor Verma has come in with superconducting electron accelerator. These superconducting electrons directly addresses the contamination in the effluent, the bacteria, and then he has collaborated with the Japanese technology and ready to launch. I consider Professor Verma like an aircraft now, completed the taxiing, waiting at the edge of the runway to take off. So I invite Professor Verma to give a presentation of his innovation and how he's ready to launch the next generation of application in wastewater. Professor Verma. You're on mute.
Thank you. Thank you so much. I don't know why my video is not coming on.
That's okay, sir. It will not come on when you are put on screen sharing. So don't worry about it. Go ahead.
Okay. Yeah. So, can you see my screen now?
Yes, we can see. Please go ahead, sir.
Yeah, we can see your screen, Professor.
So, the topic of today, my lecture today is accelerating forward to clean rivers. And I would begin by a quote from Mark Twain that Banaras is older than history, older than tradition, older even than legend, and looks twice as old as all of them put together. And therefore, there are countries which are spending for a building for their heritage. Our whole city is a heritage. And so we are all custodians of that heritage. And this is a very small attempt to restore the lost glory of Varanasi, spelt in Pali as Banarasi, from which probably the name Varanasi originated. So what is this? We want to develop the first of its kind high-intensity compact superconducting electron accelerator in collaboration with scientists from Japan, which will fill into narrow bylanes of Varanasi to transform the landscape, and has many other societal benefits, which I'll touch in the last slide. And what it will do is, these are some of the pictures of the Assi River emptying its content into the Ganges. And we would like to put a compact superconducting accelerator and make it a river at the bottom. So I'm very thankful to the Alumni Association IIT BHU for giving me this chance to present something which has I have been interested for last 1 decade, and I would be presenting it on behalf of my students who have done most of the work, Pankaj Kumar, Manisha Meena, Anjali Kaur, and Pragya Nama. And though I'm from Bombay, but मैं हूँ essentially छोरा गंगा किनारे वाला ही. So this idea was, I was going. This thing is to use the international goodwill and expertise that I have developed for last 35 years for the benefit of our nation. And the seed for this idea came from the International Linear Collider, which Japan wants to build with the aid of the world scientific community. ILC is a sequel to the Large Hadron Collider, which you may have heard is in CERN, Geneva, and which discovered the Higgs boson. So ILC is a 31-kilometer long accelerator which will collide electron and positron, initially at the energy of 250 GeV and later upgradable to 1 tera electron volts to probe the heart of matter. For our purpose, it consists of RF cavity, radio frequency cavities, magnets, cryocoolers, and vacuum pump. The idea is that we can study the property of Higgs boson, which was discovered at LHC, much better because you will be colliding two elementary particles, electron and positron, instead of composite particles, the protons at LHC. So the heart of the system is the radio frequency cavity and is the key element of an accelerator which stores electromagnetic energy and imparts it to the charged particles. There are two kinds of cavities, normal and superconductivity. Superconducting, the ILC foresees around 20,000 9-cell cavity as shown here in the figure, and they can increase the energy of the electron by 34 million volts in 1 meter of length. And all the points that I mentioned are very important for the application that we have in mind for this. They have been widely tested for stable running for more than a decade. The Japanese have perfected the art. They are very compact and very energy efficient. And these cavities have been optimized for heat losses and also for from wall to accelerator power, because the accelerator has to run round the clock, round the year for several years. So all these things have been optimized, and this would be very essential for the application that we have in mind, which I quote below. Use a similar cavity of in length and similar dimension in phi, and make a superconducting high-intensity accelerator which can accelerate electrons up to 1 to 2 MeV to treat the effluents flowing into our rivers. So the system becomes very compact, which I come to. Without wasting any more time, I come to the topic at hand, and that is pollution in the Ganges. It is well known. I will not, due to shortage of time, I will not go over it, that mainly it's the domestic and the industrial effluents which are flowing into the Ganga. And Assi is a particular case. I showed pictures which have been taken last year. And these are some of the parameters labeled at the bottom right of the screen, which show that the dissolved oxygen, the bio-oxygen demand, the chemical oxygen demand, they are all way above what is normally accepted by the Green Tribunal. And what is really worrisome is the fecal coliform, which the permissible limit is 500. It should be lesser. And it is 88,000 in Banaras. And by the time Ganga reaches Howrah, it becomes more than 2.5 lakhs. Now, when I performed the last rite of my father, I did take a dip there. And if you take a dip with such a high coliform, you are very likely to develop antibiotic resistance, which would lead to serious health hazards. So this needs to be tackled immediately. However, these pollution or treating water in an efficient and a more better way is not limited to only developing economies or a country like ours. There are contaminants of emerging concern, and as Dr. Ramurthy presented, there are in developed economies too. And what is worrisome is that small amount of the CEC class, these contaminants of emerging concern, have been found out very far from the source of the pollution. So they have, and even a small amount of this would lead to serious health hazard. So now we need a different way. I will not go over it. These are, some of the products which people all over the globe use, and these are present even in developed economy. This is a paper from Switzerland, and which is, a very advanced nation. The present pandemic has also demonstrated, very amply demonstrated, that the security, welfare, and the economics of the nation would be determined by the health of its citizens. It doesn't need more emphasis than this. And the water situation in our country, we observed day 0 in Madras last year in May and June for several days. There was no water in the tap. So demands immediate attention. So what is the purpose? Just to repeat, even at the cost of, the repetition, we want to remove harmful impurities such as COD, BOD, suspended solids. We want to, if these are from industrial, color, odor, ASSI. If you go to near Sankat Mochan, there is also odor, also TN, TP compounds. It has here for the ASSI river or for the narrow bylanes, one of the main this thing would be disinfect disease-causing microorganisms, E. coli and other pathogens, and destroy endocrine disruptors which are present in natural as well as man-made chemicals. So we are looking for our nation, we are looking for a technique which is compact, efficient, and can treat large amount of water in a cost-effective way. And broadly speaking, in the emerging class of this thing, there are 3 types of advanced treatment processes. One can guess also, we are all engineers and scientists, that you could oxidize the biodegradable waste, you could reduce them, and the emerging class are now advanced oxidation reduction process, for which I talk further. In this, the X-rays could be used, the ultraviolet rays, gamma rays, and electron beams. So the first one has only oxidizing agent, which is hydroxyl radicals. The second one has hydrogen atom in nascent form or hydrogen radicals, and the third one has both of them. In any chemical, you can either have an oxidizing agent or a reducing agent. Only in advanced oxidation reduction processes, which are based on ionizing the water, you will have both oxidizing and reducing agent, and hence it's common sense that they would work better than the first two. So here, just quickly going over these are the conventional water treatment facilities. Bioremediation has come. Also, I have not listed it because it is a green process, but with the temperature varying from 0 to 50 degrees, one has to fine tune it, and it's not so effective if you want to treat the coliform. And I don't want to go over it for a shortage of time, but if you see the row on advantages and the row on disadvantages, each one of them comes with a baggage. And that baggage cannot be just, you solve one place and you disturb another. Some of them generate carcinogenic waste, which could be harmful too, and otherwise which are just sent to the landfill. So we are creating problems for future. So let's talk of these AORP or advanced oxidation reduction processes. Ionization radiation is an electromagnetic wave with a frequency higher than 10 to 17 hertz or energy greater than a few electron volts, so that the water can be ionized. It can be excited or it can be ionized. The excited water gives you hydrogen radical and hydroxyl radical. The ionized gives you, again, hydroxyl radicals and aqueous electron, as we call hydrated electron. So hydrated electron and hydrogen atom serve as reducing agents, and hydroxyl radical and hydrogen peroxide, which is formed after the combination, gives you hydrogen peroxide. They act as oxidizing agent. So the G value determines how much such radicals would be produced, and whether you use a chemical or radiation. And normally it is seen that the G value for these advanced oxidation reduction processes are much greater than the conventional oxidation processes. So they'll be more effective. So why an electron beam accelerator? First of all, it's an eco-friendly technology. There is no secondary waste generation. We don't need any catalyst and heating. It is compact, reliable, energy efficient, and you can switch it on and switch it off as you wish. You can also use this to need for chemicals such as chlorine. As I said, it is chemical-less, so that is much better. It removes organic impurities with radiation chemical reactions. It removes color by destruction of double bonds in azo compounds. It removes odor by opening rings in aromatic compounds. The E. coli, the DNA is destroyed, so there is no question of it mutating. It is completely, nearly 100% destruction has been found, and endocrine disruptors are removed. It removes metal by redox conversion, so they take a metallic form, settle down, and you can sedimentate. So I again won't go into the details. This is a very, very busy this thing, and there's just no time. So the first column, there are a class of these things which are effluents which are present in either domestic or industrial effluents, and have a look at the rightmost column, which is removal. Some with higher dose, some with lower dose, you can reduce almost about 90%. The thing that I should make clear here is that if you combine a conventional treatment with electron beam, things work best. Oops. So I will just present one that the example. There are many that commercially also and for sustainability also it stands to reason that we should use the electron beam rather than. So this is a commercial plant design for wastewater from paper mill in Korea, and the major product is newspaper, and it uses about 18 mLds of water per day, and they were using one was coagulation and then bioremediation, and they could reduce the BOD and COD to 20 and 45, which is slightly higher than what National Green Tribunal their demand. So what they did was they combined it with an electron accelerator, which is numbered as 5, and then they have a sedimentation which is numbered as 6, and they could reach the BOD and COD level to 5 and 20, and the flow rate became with a flow rate of 15,000 meter cube per day. They had to put 3 electron beam accelerators, a total power of 300 kilowatt, but they could recycle 70 to 80% of the water, making the process very green, and the additional removal of impurities was up to 80% in total organic compounds. And the next slide shows that you can have your cake and eat it too, because they claim that the investment will be returned in 5 years. So all the cost of constructing it, which includes the cost of the equipment, cost of running, they could get back it in just 5 years, and then you get much better quality water. You can circulate much more. And the paper is from a reference, so I don't need to go further on it. This is just a cost of comparison with other treatment facilities, and this is with electron normal conducting. Now we are talking of superconducting. So this is again the study which has been done, and if you look at the cost of electron beam is the lowest per meter cube, and the cost of the BOD COD content is comparable, and as the cost. But if you combine it with another conventional process, normally it has been seen that one can get much better results. So there are worldwide water treatment plants with electron beams. But these are, and there are so many of them I saw over the years. The first study started in the US and then it has spread, but it has not spread very fast. Why? Because these normal conducting accelerators they become very large. The size, you need very high power to make it economically viable. So the size becomes large, and when you make the size large, the reliability suffers. Then the cost of shielding, these are radiation, very high 40 kilowatts or 300 kilowatts, so you have to shield it. So you have to, the cost of shielding goes proportionately high. And then the footprint becomes very large. So it will not be able, for our country, like the river, if you have been to a river, if you have seen it in there, it will not fit there. So footprints become large. And in any case, right now with space available at a premium, it always helps to save as much footprint as possible. So I am not making any claim that I am reinventing the wheel. But I saw a problem in the country, so we are making an attempt to use just top-of-the-shelf technology for urgent societal needs of our nation. So this is our conceptual prototype of a purification system. This is the way you design this cavity, superconducting cavity, which has already been done at IIT Bombay. The fabrication, we don't have such facilities. And normally for superconducting, because they have been optimized for heat losses, the total heat budget that they quote is about 4 to 6 watt. Commercially, you have available, cryo coolers at 2 watts, now 4 watt, and now even 8 watts are available. So we can, by the switch, turn of a switch, we can make, because if we had to use liquid helium, then this would not have made too much sense, because the footprint would have become larger. So you first pre-treat the water, then you irradiate, and then you filter it out, or you post-treat, and then you can allow it to flow. We have estimated that we can get about 2 kilo gray, so 100,000 meter cube can be, 1 MLD can be treated very easily. The economics, if you have to, there are 2 factors: reduce the required doses. These experiments we are doing at presently, and this is for which he also invited Dr. Ramurthy, is to optimize the dose by combining it with conventional treatment, so that you can work with lesser dose, and you improve the efficiency by going to superconducting. So higher efficiency, up to 80% you can get from wall to accelerator power, which results in low current, low cost, high current, high power, more water can be treated. Again, low cost, typical area occupied would be few meters cube, low footprint, again, saving in cost. So the milestones reached so far. This work is a part of a project that has been submitted on our behalf by the Government of India to the Government of Japan under the Science and Technology Research Partnership for Sustainable Development. This is a scheme of the Government of Japan. Under this scheme, the scientists in Japan have also submitted a similar proposal to Japan Science and Technology, agreeing thereby that they will work with us on this project. The project will now be evaluated by Japan Science and Technology, and if approved, would be funded fully by the government of the Japan. It funds only 10 projects worldwide in a year, but we had submitted it last year. There were some lacuna there about a social agency not being part of it. So they had asked us to come again. Now National Mission for Clean Ganga is a part of the proposal and has agreed to put the pilot plant. They have been very kind at Asighat. Samir, which is housed at IIT Bombay, IIT BHU, and Department of Physics BHU are also a part of this proposal. We have already designed the cavity at Mumbai, as I showed it in the figure some earlier. Fabrication would be done in Japan with our collaboration. We should be able to treat about 2 million liters of water per day. As ASSI has a much larger flow, we would be treating only a part of it, so we will have to divert it. National Mission for Clean Ganga has agreed to help us in this and take necessary permission. This is a little bit, I don't want to sound negative at it, but it took me just 2 Skype meetings to convince the Japanese that this project is doable and could be a world game changer on a global scale, not just for India, this thing. The project was evaluated by NITI Aayog and Department of Atomic Energy. They acknowledged that they don't have this technology, the nation does not have it, and it will be very useful to have it. The National Mission for Clean Ganga has acknowledged that this may be much more efficient way of cleaning Ganga than whatever are prevalent missions. As we need, I have made several attempts with Government of India and industrialists. I'm hoping that at some day I will succeed. So advantages, just summarizing, it is compact, so it can fit into narrow lanes. Reliability, these cavities, much higher requirement, 34 million volts, have been tested on test bed round the clock for years. One reference only, the time permitted. It's very efficient and economically and environmentally, it's green and sustainable. There are other applications.
Professor Verma, I think we have just got a complete overview of your tremendous application and creativity in collaborating with the Japanese companies and aligning in with the Indian requirements, particularly with the Ganges river, which is contaminated in Banaras. It's been a very high level technical revelation to us in the what next generation technology in the water application is coming, which has always been more construction oriented by the sludge oxidation process, but you have brought a complete revolution with regards to changing in and a more packaging it in a more simpler application way. But of course, the fraternity has to really look into the real technologies and the application. So I congratulate you, Professor Verma, and then we have a long way to go in getting this launch first as a pilot and then next on a commercial launch, so that we bring about really the next generation application, the wastewater treatment. I thank you, Professor Verma, and we will look forward to connecting with you and then seeing that how this can be more visible to the whole fraternity in the water sector. Thank you.
So should I stop sharing?
I think we are just getting to the end of the first session, because we have got lined up of about 6 more speakers. So I'll appreciate that, we have got really an overview. Unless there's somebody has got a quick question to ask Professor Verma, we would move on. Is anybody would like to have a quick word or any view?
I see a live question from Paritosh Tyagi. You may want to read it.
Paritosh Tyagi.
Yeah, the question is the technology of electronic beam also examined by Ministry of Environment and Forest and Central Pollution Control Board?
Yes. Before this proposal was forwarded has to be some memorandum of understanding between Government of India and Government of Japan. So on behalf of Government of India, the Department of Economic Affairs has to sign it. Before they sign, they have to take permission from Department of Economic Affairs and from the other ministries, and including Jal Shakti, which has been done.
Yeah.
Okay.
Professor Verma is in close working with the National Mission for Clean Ganga and Ministry of Jal Shakti, who are the core body to launch the next generation wastewater applications. And they are working right from Haridwar to West Bengal, entirely along the Ganges path, so that there's a huge potential for applications and enough space to really launch the next generation. Thank you, Professor Verma. I think it was a very revealing and presentation by you for benefit of all the technology and especially the next generation engineers who are really looking forward to more high technical oriented subjects like this. So we are now poised to move to the next speaker for the evening. Has Dan joined?
Yeah, he's there.
Hey, Dan. Hi.
Hey, great to be with you.
Welcome, welcome, Dan. Dan joins us from the UK. Daniel Jevons works currently with Shell Corporation in the US, in the UK, in the digitalization department. His work and the initiatives taken by the Shell Corporation is very, very significant. Digitalization, how it is going to be applied, and artificial intelligence technology on the energy sector. It's going to be a game changer with regards to digital solutions in the energy, including the oil and gas sector. The energy transition and the digitalization are the two key mega trends that will affect the world. And I'm sure what we are going to hear from Dan is going to be absolutely a futuristic application of how uh, new technology platforms can help in optimizing energy, especially the existing assets as well, how they can be more operated better efficiency. So the subject is quite new to all of us, Dan. So I'll leave you to present us what's going on in the digitalization.
Super. Great. Well, as I said, thank you so much for having me. I'm just going to share my screen. So I'm hoping that this will work well. Just tell me if you can see my screen now. Is that okay?
Hey, Dan, this is Kirti. Belated happy birthday.
Thank you so much.
Sorry, happy
Thank
birthday
you.
to you, Dan.
Thank you. Is that okay? Is that sharing okay?
No, it's not coming on yet.
Not yet coming.
Sharing
Just
is
give
not
me a second. For some reason it's not letting me share. So I'll just try that again. Hang on.
Yeah.
He needs to be made the presenter, is it not?
Well, already he's made a presenter, no?
Just check it out one more time.
Vaibhav, can you just check? Because the previous speaker was able to share.
Yeah.
It's telling me it's not letting me share for some reason. Sorry, guys.
Oh, 1 second.
I had stopped sharing, so I hope there is no problem from my side.
Yeah, no, there's no problem.
No problem.
Shankar, if he has given his presentation earlier, we can play from the host.
I haven't got that from Dan.
Oh, I see. Okay.
Yeah, sorry. I was expecting just to share, so apologies.
It was doing it all right so far.
No, in that case, let's do one thing. Let him share it and maybe one of us will present it as he goes along.
Yeah, if you could mail it to one of us.
Just going to let me just try one more time and see if I can get this up.
Yeah.
Sorry, folks.
No problem.
You are the co-host, so you should be able to share it.
Shankar, you can share your email ID to Dan on the
he has
chat
it.
box.
But I've just forwarded it. I've forwarded it to Sanjeev, so Sanjeev should have it.
Okay, I will forward it.
Yeah.
Yes, yeah. Sanjeev, maybe you can run it up.
Yeah, I will forward it to Weber.
I'll try one more
You
time.
can present it yourself.
Okay, I'll do that. 1 second. Let me just.
I think you present it. That will be easier rather than.
Okay. Let me receive it. I have not got it as yet.
The British variant.
Not getting it as yet. Dan, can you just say something? At least we'll keep the audience engaged.
Yeah, hopefully coming through okay. So do you want me to just start and we'll wait for the presentation? Is that a good way to do it?
Yeah, exactly. Just start.
Cool.
I
No
think
worries.
you can start, sharing your thoughts. Yep.
Okay, cool. So, well, look, thanks for having me, and sorry for the technical problems. I don't know if this might work. I'm just going to see if this works. Just let me try one more thing. There we go. Did that work?
There. Okay,
Can you see
yeah,
that?
it works. Yeah.
Good.
Works, yeah.
Yes, Dan, perfect. Yeah, it's
Perfect.
good.
Good.
Go ahead.
All right. Well, but look, thank you for having me, and sorry for the slight technical problems. I don't know what was going on there, but anyway, so my name is Dan Jevons. I'm the general manager for data science here at Shell, and my role is to look across all the work that we're doing in data science and AI globally. So I look after teams that are based in the US, in the Netherlands, in the UK, and also over there in India, based out of Bangalore. I've got a keen interest in India. I spend a lot of time there, so it's great to be with you. And obviously India is a key market for us and an area where we're investing heavily because of the energy needs, but also some of the environmental needs that you all have. And so I'm going to talk a little bit about that. I guess what I wanted to share today was maybe 4 key things. So the first thing is sort of building on what Shankar was sharing. I firmly believe that there are 2 major trends that are going to utterly transform the way in which things happen in the coming decades. One is energy transition. I think we've all seen that with the COVID pandemic and all the challenges that we've had around that the pace of energy transition has picked up. The commitments that companies have been making to accelerate their ambitions to get to net zero. We see those all the time. Most recently, I saw one from Infosys in India. So we see that happening in India too. And of course, digital, digital has been a growing mega trend, and in particular, AI is now becoming mainstream and is having a huge impact on many companies, but also in particular on the energy sector, where perhaps some of these technologies have been less applied historically, and we see that accelerating. And I guess what you see in Shell is a microcosm of all of that. So we have obviously a huge transition going on in the way that our business is run and the things we're focused on. And at the same time, we also have a massive transformation in terms of digital technology going on. And so what I want to talk to you about today is really the way in which we're applying that. And I really want to leave you with one key message, which is, for me, the key about digital and AI technology is that it's both an imperative for our current business to make the way that we do things more effective and efficient. And I'll give you some examples of how that is happening, as well as also very much an opportunity because it's going to be critical to our new business, and it's also going to make sure that business runs much better in the future than it does today, and very differently. And I hope to paint a picture of that. And finally, I also want to talk about the fact that openness is very much the foundation of what we want to do. We can't do this alone. We have to do it as part of an ecosystem. We have to do it with partners. We have to do it in a way that brings together academia, industry, society, startups, and the like. And I'll talk about some of the ways in which Shell is trying to do that. So a quick cautionary note, just basically saying, please don't invest in any Shell shares on the basis of what I'm going to say today. Very much sharing my own thoughts and opinions here. So let me just give you a sense, first of all, of how quickly digital transformation is happening. And I'm using Shell here as the example. Over the past few years, we've really seen a step change in the adoption of digital technology. And these are some of the current metrics that we have going on across our organization. We've got over 50 AI-powered applications that have been deployed now across our organization, which are impacting on all sorts of our parts of our value chain, right from operations, so operating our traditional assets, our manufacturing plants, our upstream facilities, right through to impacting the way in which we run our retail stores globally. I think over 48,000 of those now. We also have huge volumes of data being aggregated. We've recently aggregated over 1.3 trillion rows of sensor data across all of our facilities, bringing in our global footprint and trying to understand all of the activities across all of the sensors that we run in all of our facilities every day. And of course, this creates a huge opportunity for AI and machine learning. And we've got about over 5,000 pieces of equipment today being monitored using machine learning. and that's up from about 100 this time last year. So if that gives you an idea in the step change and the speed of acceleration that's happening as we bring together these volumes of data, you can see an exponential growth curve in our ability to deploy and manage AI models online. Similar story with drone missions. So I think, if I'm not mistaken, we were in the hundreds at the start of last year. Now we're over 1,200. And of course, having to operate assets virtually as we have had to in the last little while has accelerated the adoption of these technologies. And we have now, and you can see videos of this if you look online on the Shell.ai pages, we have robots and drones doing cleaning jobs, running inspection rounds, and identifying issues such as small, very, very tiny leaks within the plants, which previously may have gone undetected. And so those sorts of opportunities using that sort of technology is really absolutely fantastic. We've seen 10x adoption of virtual rooms powered by augmented reality, where we have remote inspectors logging into these rooms to see what's going on in the facilities. We've issued about 31 million rewards using an AI-powered system in our retail loyalty systems, and we've got about 1.7 million users registered to that. And we've got about 350 people now who are working in this space, researchers and data scientists, as well as AI engineers across the organization, and about 800 citizen data scientists, people who have been trained up in the business to be able to use some of these technologies to solve everyday problems. So just gives you a sense of the breadth and the huge scale of the opportunity that we see. And as I said, this is both having an impact on the efficiency and the effectiveness of our business, but it's also having an impact on I guess, the environmental impact of our facilities as well. So this goes both good for business and good for the environment. And I'll give you some examples of that. I mean, the predictive maintenance one is perhaps an obvious case. Of course, as many people know, when things go wrong with machinery, it has a number of negative impacts, both business-wise in terms of productivity, but also environmentally. We may have emissions coming from that. We may have disastrous breakdowns, which then lead to people having to fly out to facilities to solve those problems, and of course, replace large pieces of equipment. And obviously, if we can find small and fix small, we can mitigate all of that impact. And so we've been rolling out a global proactive technical monitoring program, which allows us to monitor all of our facilities virtually all of the time, 24/7, from 2 global locations, mainly one in the US in New Orleans, and the other actually based in India, in Bangalore, which we call the Arch. And so we're now infusing our AI-driven approaches into that proactive technical monitoring through all of that data aggregation that I talked about earlier on. And we're using that to find anomalies, and we're finding some phenomenal things and preventing things which otherwise would have had significant impact on our business, and also potentially in some cases, sadly, the environment. But gladly, we're now able to stop that and prevent that by catching it early and then arranging intervention. So that's one example. Similar example in the optimization space, we are now rolling out optimization technology that allows us to optimize the facilities of our LNG plants. Now, in the first instance, this is good for business. As I said, it's allowing us to increase more LNG from the facility, about 1 to 2% production increase. But I also wanted to flag here that this also has a CO2 impact. And many of you who have an optimization background, and I know with many of the engineers on the line, that will be the case, you'll understand that as you look at these systems, you can figure out pretty easily how to both reduce the CO2 emissions by effectively changing some of the set points and looking at some of the parameters, and obviously still operating those things safely. And also at the same time, look at how the CO2 is generated and look at ways in which that can be mitigated. And so that's been a big project for us, and we've seen significant opportunities. And we see more of that going as we go forwards, because we're also rolling out digital twins to all of our facilities. And those digital twins really have the capability to bring together even more data and help us understand in even more granularity what's going on at every part of the facility, and use that to minimize the environmental impact. And I think this is obviously highly relevant to the energy industry, but I think these approaches are also relevant to all forms of heavy industry. And we're now starting to work with our customers to try to see how we can bring some of that to them. And I'll pick that up later on in the presentation. But I talked about openness at the start, and the importance of openness. And in many cases, we recognize that many of the processes that we run today need to be monitored, often by external regulators, often by other parts of the business. In the case of groundwater monitoring, which I thought was a good example to share with you, it's sort of all of those things. We have external consultancies that come and look at the groundwater underneath our assets and our sites. We need them to submit their data in a consistent format. We need to perform consistent analysis on that. And we need to be transparent with the regulators and also with the environmental consultants within Shell to make sure we're making the right decisions. I think the amazing thing about this example, I think it's an example of the way we have to move forward, is total transparency and open source. And so we've worked with the University of Glasgow to develop what we'd built internally, which we call GWSDAT, as an open source framework. It's now been adopted by the UK government, also in the US as well, and it's growing elsewhere. Many companies have adopted this as a standard. And effectively what it is it's a tool that creates consistency. So when we say this is the environmental impact that we see, and we're going to do this to address it, it's completely transparent to the regulator that that is the case, because we're using the same framework to analyze those results, the same data science, and all of that has been subject to audit and review, and it's done in a transparent way with an academic institution. And I think this is much more the way in which we're going to have to do things going forwards. I also talked about new business models, and I think with any huge transformation, as we look towards energy transition, we see that there's going to be a change in business models, and we're going to have to work with we're going to have to create new ways of making money, and we're also going to have to work with our customers in new ways. And so I thought I'd share a couple of examples of how we're already doing that. At Shell, we believe one of the key elements to mitigating many of the impacts around climate change is going to be carbon capture, utilization, and storage, and actually putting carbon in the ground as much as we possibly can rather than generating emissions. And I think that ties very closely to the theme of this session. But of course, what we also recognize is that AI is going to be key to that, because we need to verify that what we put in the ground stays in the ground, and we need to be able to do that in a way that regulators are satisfied that that's the case. And so we've been doing this already at scale in the Quest facility. We put over a million tons of CO2 per year into the ground at Quest. And we use AI to monitor that both above the ground and beneath the ground increasingly. And we're working hard to make sure that those frameworks are robust. You may have also heard we've committed to a new program where we're trying to model a whole supply chain around the carbon capture and utilization and storage opportunity. And so we're very much focused on that and trying to make sure that that is going to emerge. We're using the Northern Lights program, which we're working with Equinor and Total on, to try and demonstrate that integrated supply chain. And digital technology is going to be key to that. We're partnering with Microsoft to develop that technology, and we see that as a huge opportunity. And then in our customer space, we're also working with many of our heavy industrial customers to roll out similar technologies to the predictive maintenance technology that I talked about earlier on, to help them improve the monitoring of their processes. And one element is lubricant monitoring. Many of you will know that lubricant monitoring is a very effective way of identifying issues with machinery. And so we've packaged that up into an offering which we call Shell Remote Sense, and we're rolling that out to a number of our customers already. But of course, all of that's not enough. We also see that there's going to be a huge impact and a huge need to totally transform the way in which we generate energy. And so I thought I'd talk very briefly about 3 examples of that as well. We're working very hard on electric mobility. We've rolled out to date over 165,000 electric charge posts through our partner companies, or our wholly owned subsidiaries, I should say, Greenlots and New Motion, as well as rolling out stations, similar charging stations at our retail forecourts as well. And so we see that charging infrastructure growing exponentially. And as we do that, of course, we need to make sure that it's cleaner. And cleaner means that we need to make sure we maximize the use of renewables as much as we possibly can, because that's the whole purpose of, or one of the main purposes of moving to electric vehicles. And so to do that, we need to be able to optimize the way in which these vehicles are charged. And particularly at the home, making sure we take advantage of points in the day when the maximum amount of renewables are on the grid. So we've developed sophisticated optimization algorithms, which we call smart charging, which allows us to optimize the way in which these vehicles are charged. Similar scenario in the hydrogen domain, where we're increasingly rolling out hydrogen to our retail stations, but also as part of electrolyzer projects more globally. We've got a huge one which we just committed to in Rotterdam. And the key point around these projects is that a lot of them are new processes. We need to develop hydrogen infrastructure. We need to develop the solutions around how that can be scaled. And we rely heavily on combinations of physics-based models and AI to allow us to scale that up. And then, of course, we also have, we're also investing heavily in wind technology. And as we do that, we need to optimize the layout of these sites to make sure that they are on as much as we possibly can make them, that they generate the maximum power output, and also that they're combined with things like hydrogen and battery technology in effective and sophisticated ways. And again, there we rely heavily on optimization technology, on physics-based models to understand that, and then to design the way in which we're going to roll out these wind farms, and then to make sure that when they're operated in the most effective way. So very similar to some of the optimization approaches that I talked about in our traditional facilities, now being applied in the wind domain. And I guess building on that theme, I also wanted to make clear that we're not trying to do this all by ourselves. I talked about openness. And I think the key thing here is that we are trying to work with partners in academia, with startups, and many of them in India, to try to bring in the best ideas, because these problems, these environmental problems, these energy problems, which we have as a society, are not easy problems to solve. In many cases, we believe the technology is not fully there. And so what we're pushing for is a number of approaches whereby we can bring in brains like yours to work with us to help us to try and solve some of these problems. So last year we ran the wind farm layout optimization hackathon. If you haven't seen that, maybe check it out online. It's available on our website, and also you can find it on LinkedIn if you search back through posts. The key thing about that optimization hackathon is we tried to particularly focus on India and ask some of the brightest minds to come and look at some of our data sets and say, what are we missing? What are the better ways of approaching this problem? We got some fantastic results from that. And we're trying to repeat that this year with Game Changer, again, looking at waste management and how we can help frontline waste workers, again, particularly in India, with solving some of those really tough challenges that you face, and trying to open source, again, some of the data sets that we have around that. And then I think we also have a startup program called E4, where we run annual cohorts of startups, which we bring in. We invest in those startups, we mentor those startups, and we look to try to accelerate the scale up of those startups, in particular in the energy sector. And of course, we also are trying to build in-house capability. We've recently rolled out the residency program in India to try and bring in the brightest minds into Shell to work with us on some of these really tough problems. So I'm conscious of my time. I just wanted to say, to summarize, I've covered a lot of ground very quickly. And of course, you know, what I wanted to do was give you a flavor of all of the things that we're trying to do right across the value chain in around 20 minutes, just to give you a sense of the way in which we're approaching these problems. But just to kind of bring you back to the main points, as I hope you'll agree with me, digitalization and also energy transition are two hugely important trends that we need to address as society, to embrace and to take on and to embed into the way that we do things. And that's not easy. To do that, we recognize that we've got to play our part, and we're investing heavily in digital and AI as part of making our existing operations more effective and efficient, trying to minimize the impact of those, and also in trying to develop new technologies that are going to shape the future energy system. And I guess to re-emphasize, openness is foundational to what we're trying to do. We want to work with partners, with academia, with startups, with society, because we recognize these problems are not easily solved, and we need to do it together. So with that, apologies for the technical problems. I hope we got there in the end, and happy to answer any questions if we have some time.
Very interesting, Dan. You have clearly eliminated the human intervention in gathering data and analyzing it. It's all very transparent in digitalization and artificial intelligence, which gathers the data in a uniform way. My view is that you could work more closely also with the regulating authorities because most of the assets that they perform, if there is a malfunction, the regulatory authorities also have to intervene to ensure that the corrective actions are taken appropriately at the appropriate time. So it's not only the monitoring, but it also the ensuring that the corrective and preventive actions are taken to an open and transparent digitalization. That's also a great application I can foresee.
Absolutely.
Uh, there are some questions from our audience. We can take on to Dan.
Yeah, I think he touched upon the digital twin concept. I just wanted to know what are those areas where digital twins are being used by Shell and to what benefits?
Yeah, great question. And I think maybe just to start, I think the challenge, digital twin is one of those terms that means a lot of things to a lot of different people.
Yeah.
What we talk about is the fusion of both data and models that represents the physical reality of the asset that we're talking about. So it's for us, it's very much data and models coming together. I think up until last year, we'd been very much in the experimentation phase. We've now completed our first full-scale deployment of a digital twin, which we did at the Nyhamna gas plant in Norway. And it's a phenomenal thing. We've really demonstrated that we can integrate all of the historical documentations, engineering documents, diagrams, the sensor data, the real-time information flowing from the plant, from the actual DCS system as well. And we've integrated all of that into an integrated platform which can be queried and explored and used as part of the day-to-day operations of the plant. And that's been absolutely fantastic, just a real step change for us. We're now trying to build on that success and replicate a similar approach globally. We are working hard on trying to roll it out in Trinidad and Tobago. We have several other assets on the roadmap this year. And the plan is to gradually scale up across multiple assets globally to full-scale deployment in around 18 to 24 months. Now, as I said, we're building on a lot of things we'd already done. We'd already brought together a lot of the data that we needed, and we're now trying to just create an additional framework. I think the huge opportunity is to, once you have that digital twin, is in that optimization domain, where a lot of the scenarios we're looking at is how could you run all sorts of what-if scenarios across the asset, and then try to understand what the impact of that would be before rolling it out, and allow people to do that real-time testing without having to run actual experiments. And I think that is extremely exciting and very, very powerful as we look to have an impact on some of the things I was talking about today.
Right. Very exciting.
Very exciting next generation applications on digitalization, particularly on energy management and waste conservation and pollution control. Any more questions from the audience before we move on to the next speaker? Because this is a very interesting subject.
I just wanted to know if we can read somewhere about how is it a game changer on waste management. If you could share some literature, some website.
Yeah, I'm absolutely happy to do that as a follow-up for this community. No problem. I'll get you all of the latest information. We're sort of in between calls. The wind farm layout hackathon has happened and finished late last year. The next one will be on waste management, and that's just being framed up. But I'll get you the information on that. And obviously we'd love students from.
Yeah, well, I'm not exactly a student, but one teacher is also always a student.
Teachers are also very welcome.
Yeah.
Look, even better. Absolutely.
Some AI, artificial intelligence or machine learning for my data analysis in high energy physics. So it would be interesting to see how you do it for waste management.
For sure.
Thank you.
Happy to share.
So thank you, Dan. It was a very exciting to see that the next generation of asset management through very transparent way of digitalization. So we look forward to receiving more input from you so that we get to see more applications in India that we can leverage the application that you already optimized and presented to the rest of the world. Thank you, Dan.
Super. Thank you so much. Thanks for having me.
Thank you.
Thanks, Dan.
Thanks. Bye.
If you can just stop sharing the screen.
Yeah, that's very good.
Yeah.
Good. So next we
Yeah,
move on to
Mr. Shankar, sorry to interrupt. Before we move ahead, we have this video clipping from the e-cell.
okay.
Yeah,
Please go ahead.
Now invite Ranga, a member of the entrepreneurship cell, to talk few words about e-cell and also present a video.
Hello everyone, I'm Ranga Sudarshan, the Web and Branding Head of eCell IIT BHU. The Entrepreneurship Cell IIT BHU is an institute-run body run by the students devoted in acting as a symbiotic link between entrepreneurs of eCell, IIT BHU, and the existing startup ecosystem. It also acts as a hub where all the startups can meet, collaborate, and innovate. The economy is tightly connected with environmental conditions, and we can't be speaking about the business ecosystem without keeping in mind about the environment we live in. Abnormally high temperatures, natural catastrophes, and poor air quality are only a few signs of ongoing climate change that affects the environment. Business and technology are the forces that can impact the environment in a global scale. With more and more enterprises joining social and environmental matters, it proves that the future of sustainable living is more promising than what forecasts were estimating. Fortunately, many startups incubated in MCIIE, the incubation center that is situated in IIT BHU, that those startups fully dedicate themselves to finding solutions to global problems and creating social impact. Currently, MCIIE has incubated 25 startups. Ravi, the agribusiness incubator, has incubated 19 startups that have secured their funding under the Raftar scheme. The role of eCell in promoting startup culture is supreme, ranging from startup services to startup 101 lecture series. eCell strives towards nurturing the startup into becoming successful business. Not only that, eCell also plays a key role in promoting entrepreneurial spirit among the freshers by conducting regular competitions like Chase Unicorn, orientation program, Google Startup Weekend, and the mentorship program, where sophomores guide the freshmen with their general entrepreneurship related queries. So here's a short clip about the activities eCell does throughout the season that will give you a very good idea. So I'll request Vaibhav Ching to share the screen and play the video. Thanks.
Hey, that's a treat to watch. That's an amazing video, Ranga. Looking forward to all the great work that to be done by the eCell. Over to you, Mr. Shankar.
Okay. Thank you, Kirti. Ranga, that was really inspiring to see that ESL Institute is taking rapid strides in the entrepreneurship. The institute has come a long way, and we are very heartened to see all these activities are taking shape to groom the student and the emerging students into a very right path and the entrepreneurship. I'm very happy, and your video was very well presented. I congratulate the ESL on this. So we move on for the evening session with another exciting technology presentation that's going to come all the way from United States by Alex, called Alexander Walczak. He's come. Thanks for joining us, Alex, on a Sunday morning from the US. And Alex is an impact entrepreneur in clean technology and renewable industries. As an industry leader, he works globally with impact and investors and strategic enterprises and in association to accelerate sustainability revolution. Alex has spearheaded a very differentiated technology, I would say. We all know conventionally the source of water is rainwater, river water from the melting glaciers. Then there's groundwater, and of course there's the seawater. There's no dearth of seawater, but there's a cost to converting it for human use. And man has contaminated all of this, and their sources are also getting depleted and limited. So what's the next source of water? That's where the invention or the development of technology from Alex has come from a company called Sky H2O based in California, US. It is called the atmospheric water generator. It's very good to know that there's a lot of water in the air in the form of humidity. And the technology that Alex has applied is to collect this water in a very efficient way from the atmosphere and then produce drinking water. I must also congratulate him because not only he has invented, but he has also launched it commercially and across the globe, and is now poised to go in big strides. So let's go and hear out from Alex how he has started this technology and how, or the nuances of this technology and how it can be made more commercially viable for implementation across the globe. Alex has also studied a lot of geographies in India as well to launch this product and technology, not only across the globe. He's focusing primarily more on Middle East, US, and India as well. So Alex, welcome to this webinar, and we are all ears to hear out your presentation and see how we can learn from the next generation. It gives us the comfort that there's a source of water freshly going to be available.
Good morning from California, and thank you very much for that kind introduction.
Yeah.
Can you hear me?
Yeah, we can hear you, Alex.
Can you see me?
Yeah.
Yes.
Okay, yeah.
Good.
Good morning from California, and again, thank you very much for that kind introduction. I'm very honored to be with you today and to present to your illustrious group and alumni and university the idea of atmospheric water generation, and also some details about my business, Sky H2O, who we are, what we're doing, and where we're going. I've prepared a presentation for today's discussion. How do we get that up on the screen? You have that, or I need to do that?
You can share the screen, Alex.
I sent you the presentation. I apologize.
Shankar, you can just share the screen. Or just send the presentation to Vaibhav, we will do it. Vaibhav Jain. Just forward it to Vaibhav Jain.
1 second. Oh.
He wants you to upload it.
Yeah.
I sent it to you a few days ago.
Okay. Sanjeev, you have that? I think he sent it to you and me.
Let me check.
I think, yeah.
Alex, you can start.
Start. You can start talking about it by the time we figure out the presentation to be made.
Yeah. No, I just have to escape. Okay. So we'll bring the screens up in a moment, but I can tell you firsthand about the situation. Again, my name is Alexander von Welchek. I'm the founder and CEO of Sky H2O. Sky H2O is a California innovation company. And what we're doing at Sky H2O is not just innovating, but truly advancing and scaling.
I've got the presentation up. Can you all see it?
Yes.
Yes.
Okay, go ahead. Yeah.
So Sky H2O is not only an innovation company, but what we're doing is we're truly innovating and scaling a new industry. So what is the current situation globally? Well, unfortunately, it really seems the world is how do I move through the slides?
I'll change if you want.
You can go to the next one. The world is running out of water. Currently, depending on how you measure it, about 3 billion people, close to half the planet, live in water stress. And by 2050, we expect to need about 50% more fresh water. But on the other hand, by 2050, we expect to have about 50% less fresh water because of climate change, because how mankind has blindly exploited groundwater and other sources of water. And therefore, there's a huge shortage. We can go to the next slide. Currently known to man, there's only 3 ways of obtaining or creating fresh water. One way is through different forms of forward or reverse osmosis, which is essentially cleaning up existing bodies of water. That includes desalination, which is the most well-known way at the moment. The other way is a distillation process, basically an evaporatory process, but no one's really figured out how to do that practically, where we can make significant amounts of water in a reasonable cost. And the third way is what we're doing at Sky H2O, and that's atmospheric water generation, which is essentially squeezing the water out of the air. We can go to the next slide, please. The air has a very significant amount of water in it globally. Some would say that there's essentially as much water in the air, in the atmosphere, as there is almost all freshwater sources combined. And with climate change, with temperatures rising, we have much more evaporation, which is creating even more water in the air. In fact, it's been proven or said for every 1 Celsius increase in global temperatures, we end up having 7% more water in the air. In fact, this additional water in the air is the primary culprit behind the dramatic weather changes that we're seeing, where storms tend to be bigger and stronger. So it's that water in the air, which is the resource that atmospheric water generation uses to create fresh water. Next slide, please. Atmospheric water generation, as opposed to any other technology, is really game-changing in its business model or applications, because now, really for the first time in the history of man, we can make water at the location where the water is needed without having an original source of water. So again, the real difference between atmospheric water generation and any other form is any other form requires an original body of water, be it a river, a lake, groundwater, ocean, etc. In the case of atmospheric water generation, our resource is the air, which is everywhere. And as you can access that, you can now make water projects in almost any location, allowing you to forego expensive, perhaps non-existent, perhaps decrepit infrastructure, so that now you can put water generating systems at the most critical locations where water is really needed. For example, perhaps directly next to and at a hospital facility, perhaps at a university campus, perhaps if there's a military operation. Also, the rolling out of these systems can be relatively quick compared to any type of traditional infrastructure type approach, so that in the case of emergency or disaster relief, you can bring in systems to make fresh water right there where you need it. We can go to the next slide, please. So again, the world is running out of water. We expect to need about 50% more fresh water by 2050 because of population growth, because of how a significant part of the planet is quickly moving more to protein diets, including a large portion of India, which creates a much greater need for water, industrialization, and so forth. And of all the different technologies evolving available, it's expected that atmospheric water generation going forward over the next 10, 20, 30 years will play a very, very big part in solving the water equation. I myself am a pioneer in renewable technologies. Since about the 2002 timeframe, I've started a couple very significant solar companies. And I'm sure you've all now seen how solar energy has really changed the energy landscape. We just heard it from the Shell colleague a moment ago. Back in the 2002, 2003 timeframe, we could barely make a solar project work for under 22 cents a kilowatt hour. And today, solar projects are getting signed up for 2-3 cents a kilowatt hour. And that's been a technology that has changed the landscape of energy also, because these solar projects can be rolled out quickly and in smaller scales, really wherever the energy is needed. And I draw a very similar comparison to atmospheric water generation. It can be rolled out quickly and at the locations where needed. Next slide, please. And we can go to the next one. Thank you. So again, Sky H2O, our mission is to be the world's greatest supplier of atmospheric water generation systems. And what we're doing is we're scaling this young new industry to make bigger systems, to make more water. So if you look perhaps at the competitive landscape, of this young new industry, one way or another, you might find a dozen or so companies around the world, including a couple from India. But what you'll find is most everybody is only able to or working with small systems that might be appropriate for residential or some kind of small commercial application. At Sky H2O, what we're doing is we're making bigger, more robust systems that work very well for larger commercial, industrial, and government type applications. We have, as a starting point, introduced to the market about a year ago our flagship system that we call the Maximus AWS. And that system essentially looks like a 40-foot container, and it's rated to produce up to 10,500 liters of fresh water a day. Let me explain the rating for a moment. Atmospheric water generation, again, is a renewable resource as it mimics nature in an environmentally friendly way. So again, I draw parallel to the other renewable resource industries like wind or solar, where of course every location there's a different performance. In wind, you need to have, it's all about capacity factors. We just heard from the Shell colleague how they're always kind of trying to tune up and figure out productivity there. In solar, it's about the insulation, to get good output. And in this case of atmospheric water generation, the primary driver of efficiency is relative humidity. So the systems don't necessarily work in every location, and in certain locations, they work much better than others. With the rating of 10,500 liters for our Maximus, that's based on having atmospheric conditions of 27 Celsius at 80% relative humidity at sea level over a 24-hour period. If we have that, the system will produce 10,500 liters, and based on different conditions, it'll produce different amounts. So approximately 70% of the people in the world live in locations where the average relative humidity is over 65%. So that's essentially the areas in the world where atmospheric water generation and Sky H2O can do well. As I mentioned, what we're doing at Sky H2O is truly scaling the industry, and you'll see here on the slide our next generation product that I'm revealing and we're bringing to the market late next year or this year, which we call the water security tower. The water security tower essentially looks like a traditional municipal water tank. We integrate atmospheric water generating technology essentially in the rooftop, and that system is going to be rated to produce about 100,000 liters of water a day, so essentially 10 times that of a Maximus system. And then also in the near future, we'll be introducing to the market rooftop building integrated, so that buildings in the future can also produce, store, distribute, manage its own water, so they can be essentially off water grid or have more water security. So similarly how elevators have allowed buildings go up, 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 and HVC has allowed buildings to be built in places like Riyadh and Tucson, Arizona, which wouldn't have been possible in the past. We think building integrated will also be a game changer, allowing more development in areas that are very water stressed. Next slide, please. Next slide, please. So again, we think what's very valuable here as it's a game-changing technology, is allowing for distributed networks. The reality in today's financial world is most governments, states, municipalities no longer have the resources, no longer have the credit rating to be able to make big, bold municipal investments. We're seeing very often cities, citizens, companies kind of stranded because the cities are not capable of providing the services, water, energy, security, transportation, all those kinds of things. Therefore, we see the distributed generation happening more and more, where essentially those are taking their future in their own hands by generating their own energy, providing their own security, providing their own water. And that's where this plays nicely. Next slide, please. Again, atmospheric water generation mimics nature. It's a renewable resource and works in harmony and balance with nature. Next slide, please. Sky H2O is a California innovation company. We possess significant amounts of intellectual property. We have designed, invented, engineered from the ground up our own technology, our own systems. We started our business in 2016, including help and collaboration from some very prominent professors and scientists from University of California, Berkeley, as well as Stanford University. Our chief science advisor is Chancellor Professor Tarek Zodi, the head of the engineering university or college at UC Berkeley. And what essentially we've invented is what I describe as an air-to-water engine, which we believe is the most efficient and practical in the world for commercial or industrial scale atmospheric water generation.
Alex, meanwhile, I just wanted to intervene with a question from one of our audience which has come. Maybe we can take that quickly. The question is, will there be any significant impact on local microclimate and ecology due to dehumidification of air by collecting water from air?
That's a very good question. And you probably can appreciate us getting a lot of advice from specialists at University of California, Berkeley, who's considered to be highly environmentally responsible. That's been always top of mind. And what I can say in general is for projects that are small or medium of size, which means perhaps projects that generate 10, 50,000 liters a day, even up to 100,000 liters of water a day, that will have minimal, no impact on environmental conditions nearby. The reality is there's huge amounts of water in the air, and the air is moving around quite well. On the other hand, as we get to much larger projects, that could quite possibly have an impact. And in those cases, just like in the wind industry or even the solar industry, we'll need to make an environmental impact report and assessment to understand the air movements and so forth, whether or not that would make an impact. But I would say generally in most occasions, there will be limited or no impact. In fact, some could even argue that by taking water out of the air, we're helping climate change, because as you likely know, the water traps in the air, traps the heat. And that's also what's accelerating global warming.
Yep. Thank you, Alex, for a very impactful answer. Thanks, Paritosh Tyagi. That question was from Paritosh Tyagi. It is a very significant question that he has asked. So I think we are well on time. I think in conclusion, Alex, the products that you have launched is very, very relevant to what we are looking forward to in the water stress areas, particularly the one that is the water security tanks, which is mounted right up on the top of the buildings or mountains. So we are going to save considerable energy of pumping water, especially in a tall buildings, pumping water all the way from ground to top and then distributing. Rather, we are generating at that height itself. That itself should prove that it's very significant in energy savings. So,
Mr. Shankar, if I may have a few questions from Mr. Alexander, is it okay?
Yeah, one question maybe we can accommodate, sir.
Okay. Alexander, can I call you Alex?
Absolutely.
Right.
Yes.
Alex, my name is Deepak Pava. I'm quite familiar with some of the technologies. Very good presentation. And I think what is good and impressive about your technology is that it allows very large quantities of waters to be produced from the atmosphere. Producing water from atmosphere is not unknown. It's been available for a very long time, as you know.
That's correct. Yeah.
And but when we were younger and taught various options for water production from various methods, compression was supposed to be one of the most uneconomical methods, compressing air to bring out the water, and it had its limitations in terms of geography, especially if you're looking at desert and desert areas. So what we are seeing is an emergence of three competing technologies which are already there in the marketplace. One is the refrigeration type. The other is, of course, from Berkeley, your colleague, Dr. Yagi, who was also, I think, recently nominated for being a Nobel Prize winner. He's come up with a lot of adsorption-based technologies called Waha Incorporated. And there's also another one in Arizona, which is zero mass water, where they use desiccant, rotary desiccant systems. And that's commercialized and all over the world. They are limited to small quantities of water, but using adsorbents have the advantage of not having to use electricity. And compression is highly dependent on usage of electricity. And if you can decouple electricity and depend on the solar energy, that is one way which the world is looking at. There's a startup in India which has done that. We ourselves are very actively looking at this technology, building prototypes in the next few weeks, because we are an adsorption-based company and understand adsorption. So I've been scanning the landscape, and I think yours is a very interesting option. And it's good to hear you, but I thought I would share my experience and have you give us a wider experience to the audience on that.
Absolutely.
Thank you.
Thank you.
I very much appreciate that. Let me just make one comment. Yes, the amount of energy required is, if you will, the Achilles heel. And of course, we're always working on making it more energy efficient. At the same time, we ourselves know quite a bit about renewable energy networks. And what we're seeing in many, many locations in the world now is energy being made available literally for free, or perhaps even they'll pay us to take the energy, because as we're getting these renewable energy networks that are 75, even 100% renewables, they need to be oversized. And in lieu of having energy curtailed or even penalized, let's say at a wind farm or a solar farm, or put into very expensive storage, we can take that energy as a smart device that works together with the grid and make valuable water out of it. So this is also a play to work interactively with renewable energy networks. And that's also why we moved, our company's based in Irvine, California, and we work very closely with UC Irvine with the Water Energy Nexus, the WEX Center.
That explains a lot. That explains a lot.
Yes. Thank you, Pawaji and Alex, for an excellent presentation on the next generation of water.
Thank you very
So
much.
we will share your presentation with Mr. Deepak Pava and others who are keen interested in knowing it further. So thanks, Alex, once again.
Thank you, gentlemen.
Okay.
Appreciate being involved in this event.
Surely.
All the
We
best.
look forward to more connecting. Next, we move on to another interesting application of technology that is on the wastewater side, but this is on the other side of the wastewater. We always talked of wastewater. A lot of discussions took place in the morning sessions as well on the new technology that are getting applied. So traditionally, we have been focusing only on wastewater technology, how pure water can be extracted out of the wastewater streams. Fine. But have you ever thought that, we all know that one form of mass can be converted from one form to the other, but it cannot be destroyed. So when we extract the clean water out of the wastewater, there is something called as a sludge that left behind. That is basically what the active bacteria that completes its life cycle and gets converted to a dead mass. That is called as the sludge. Conventionally, the huge wastewater plant that have been operating in India and still operating in several places have been accumulating this sludge, and people used to look away from that, and it's wishing away that it doesn't exist, but it's the truth that it is existing. So we have Rob, who has championed this application of sludge from wastewater into an organic manure. It's a fertilizer, and he has already not only championed, he has applied it in India extensively. Although Rob lives all day in Toronto, Canada, his heart and mind are in India. He has established a facility in Baroda, which is running, and it is producing FCO compliant, that is called Fertilizer Ministry Compliant Order fertilizer, and is collaborated with big companies like RCF, NFL, GSFC, and is producing organic fertilizer. So over to you, Rob. He knows India better than most of us do on the Indian soil conditions. So Rob, tell us how you have applied the waste as a source for agriculture industry.
Right. Thank you very much, Shankar, for that kind introduction. I'm wishing I was in India now. I'm looking out the window and there's 6 inches of snow that I'm going to have to go and clear off my driveway that's arrived this morning. So thank you for inviting me to this great conference. I've been listening. You've got some great presenters in the past here, and I hope that I can only keep up with that quality. I'm going to try to share my screen here. I have a presentation that I'll quickly go through.
Yeah, we can see your screen, Rob. You can go.
You got it now?
Yeah, we got it.
Great, thank you. So I'm hoping that at the end of this presentation, I'll be able to convince at least a few people here that what we need to begin to think of organic waste, not as a waste, but actually as a resource. And in particular, I'll be focusing on the waste, the organic waste that's coming out of a sewage treatment plant. But of course, we have a number of other sources of organic waste as well that we can have the same vision about. Doesn't seem to, oh, there we go. So our current practice for sewage treatment plant waste, as Shankar spoke to, is that we either landfill the material, or in some cases, it's actually applied directly to the field. Now, unfortunately, the experience around the globe is not so good about either one of those practices. In fact, in Ontario, Canada here, I have a town not too far from where I live, where organic waste was placed near the source of groundwater. And what happened was, I think 10 people died, and the town was basically shut down because their groundwater source, their well water, was basically contaminated with the leachate coming out of the sludge that was placed on the farmer's field in the hopes of fertilizing the field, but in fact, it was actually percolating down to the groundwater. So the practice of landfilling or direct farmed application is not exactly sustainable, nor is it safe. But we do know that in sewage treatment plant waste, it is actually an interesting source of organic material that farmers could use. And in fact, it could be said that sewage treatment plant waste is much cleaner than the material that the organic waste that can be sourced from the organic component of our wastewater, of our waste stream. So our technology was created a number of years ago in Canada here to promote the change of thinking from organic waste as a waste stream to it being a resource stream. And in fact, that's a picture of the product we currently make in Canada here, and we are now making in India. That is an organic fertilizer that's been produced using primarily organic waste, and in this particular case, about 80% sewage treatment plant waste. So why is this a sustainable solution to organic waste? Well, our product, which is called Ceres Grow, retains essentially all of the nutrients that are found in the organic waste itself, versus commercial fertilizer, which when it's applied to the field, the majority of which leaches out into the water system. About 60% of a urea application will not meet or reach the root system of a plant. It will leach out or simply not be absorbed by the plant. And so, in fact, when you're spending $400 or $500 Canadian for a ton of urea, you're spending a lot of money for a product that will not actually fertilize the product. Our process actually provides a credit, a GHG credit of up to 2 tons for each ton of organic waste. But a commercial fertilizer has a rather high carbon footprint. We reuse organic waste. Commercial fertilizer consumes a non-renewable resource. There is only so much phosphate in the ground in the form of a phosphate mine. Reusing organic waste will minimize wastewater discharges and contamination to water sources. Commercial fertilizer, as I said earlier, actually, a lot of it ends up in our water stream. Ceres Grow, our organic product, returns organic carbon to the fields and soil. Commercial fertilizer has no organic contribution to the soil. Indian soils are not too much, unfortunately, like North American soils. Because of the heavy use of farming, we tend to consume the organic content in soils and not return it back to them. And in fact, the overuse of urea in a lot of parts of the world, including India, is further hurting the retention of carbon in the soils. Indian soils are carbon deficient. Talk to anybody at the Ministry of Agriculture in India, they'll tell you that. And so there needs to be a process to return carbon, organic carbon in particular, to the soils. So is our product safe? Since it's one of its primary raw materials is sewage sludge. The answer is yes. EPA, is the USA Environmental Protection Agency, has a regulation. It's called EPA Part 503, and it classifies products made from sewage sludge into 3 categories: EQ, which is exceptional quality biosolids, or Class A product biosolids. Our product would fit into the EQ category. Unfortunately, material that is taken straight from the sewage treatment plant and not properly processed is Class B. And it's not, in large parts of North America, Class B application to agricultural fields in a Class B form is actually now being banned because of its potential to contaminate food products. So why are we looking at sewage treatment plants as a source of organic material? Well, just on these three components alone, suspended solids, which is effectively organic matter, nitrogen and phosphorus, there's a significant concentration of those materials still resident in the sewage sludge after processing of the waste stream. And if we take those numbers and using your population in India of approximately 1.3 billion people, about 2,200 liters per day per person on average being consumed, being produced by individuals, then this is the total volume of these components alone that is in the waste stream. 980,000 tons a year of nitrogen. And that would be organic nitrogen, by the way, not inorganic nitrogen. 2.9 million tons of carbon, 590,000 tons a year of phosphorus. And this is a yearly volume. Every year that material is now currently being disposed of in a landfill, primarily, or not recovered and dumped in a water stream, or being applied untreated to farmers' fields. This volume is the equivalent of 2 brand new urea plants each year in fertilizer volumes that we could harvest, literally harvest, and apply to the fields in India. So we also have another stream of organic waste, and that's the food waste in our municipal solid waste stream. North America has pioneered and gotten involved in, Europe's done it as well, a source separation program. It's not quite being developed in India, but you're going there. That's good because, again, that is another source of organic waste and another source of nutrient material that could be applied to farmers' fields. I won't go into the specifics here, but this is some data that's been assembled from one of the state ministries. Here's an interesting figure. So most of the municipal urban corporations spend about 500 rupees to 1,500 rupees a ton, but about 60 to 70%, and I think that number might be low, is spent on collection alone, not processing and not managing the material once it's collected. Very little of the funds are actually spent on how best to convert that material into a viable final product. About 30 to 50% of our solid waste stream is actually compostable or biodegradable, which means it has an organic component to it. And because of the quality of the issue, because the organic material is not readily collected separately in India, the price of this material, once it's converted and sold, is about 3,500 rupees a ton, up to 4,500 rupees a ton, because in some jurisdictions, good quality product is not readily available. So there's a final source of organic material, and that's organic waste from the actual farm itself. And in India, like in many parts of the world, agricultural waste is being converted into a sustainable and non-polluting cheap energy source that is lighting up the villages and changing a lot of lives. I think you actually have a presentation today about bio to energy. Agriculture can also be reused not only as a fuel source, but it can be reused as a nutrient source for the fields. So field waste can include weeds and straws. There can be animal waste from the farm as well, which is animal manure and animal waste. And then there can be industrial waste coming from the food source, from the agricultural source, which would be sugarcane waste and molasses. I think in some parts of your country, the sugarcane waste is actually burned just to get rid of it. So what's the value of this product? So yeah, you can make a product. So is it any good, and why would the farmer bother to take it? Well, simply because it contains at least two, and I would argue the third is the most important, very key components: nitrogen, phosphorus. There's a little bit of sulfur, which is helpful in some of the products and fields that you're growing your products in. But what's not on this chart is the organic carbon component. And if you take all those four together, it achieves, and it can achieve, the nutrient need of a field based upon the crop that's being grown. It may mean that you're applying 5 bags of our product versus 1 bag of urea if all you're looking for is nitrogen, but you're using a totally renewable product, and it's a sustainable process because each year those volumes of nutrient, of nitrogen coming from the wastewater stream is there. This is a chart showing, we sample our product in a number of parameters, but this is a chart showing 2 test results. I just showed you December 2016 and the December 2020 test result. But we do it every 2 weeks now. And FCO is a fertilizer control requirement, if you will, for an organic fertilizer registration. And you can see that the product is relatively consistent and as it relates to its concentration nutrients. The nutrient concentrations are relatively low. So in the test results are showing we have 2.3 to 2.5% by volume of nitrogen in the product. Carbon would be anywhere between 14 and 15 to 16%. So it's not a high concentration product, but these are all organic nutrients. And there's a huge difference, as some of you may or may not know, between an inorganic nitrogen and organic nitrogen as it relates to how it behaves in the field and how the plant will actually absorb that material. This is comparing our product, same parameters on the left-hand side versus a product called City Compost, which is the composted material of the green portion or the organic portion of a municipal solid waste stream. Again, we compare very favorably to straight compost material. So, yeah, you can apply commercial fertilizer, and it's applied in a number of cases. Straight urea, DAP, which is a combination of nutrients. But each one would be deficient in a key component of nutrient. Urea just has nitrogen. DAP does not achieve the recommended targets for sulfur. APS does not achieve the recommended targets for phosphorus. So if you really want to do a proper field application, you need to do at least 3 or 4 different commercial fertilizer applications. Versus if you used R, it's one application of one product, and all the applied nutrients are organic. This is the slide deck will be available for you to look at shortly, but I need to move along to give you some video pictures of our actual production process. But these are the benefits of applying our product to a field versus a commercial product. Yes, Shane.
Rob, that will be interesting to see some photographs of your commercial process so that we all can see what's really happening in India with regards to manufacturing of this. So maybe we can wind up with some photographs of what your production facilities are.
Okay, I'm getting there right now. So our process is a 2-step process. We consume as raw material all waste streams, and we produce 0 waste. This is a picture of some of the organic waste material we consume. The top right-hand picture is sludge, and the bottom picture is a mix of food waste that we would collect. So we take organic waste, we add an alkaline material, in which in India is we're using fly ash from the cement production business, and the power production business. This is a picture of our mixing technology, and literally it's a mixing process. So if I go back to this chart, the first step is really a chemical process that was created in one of the universities in the US. And our first step is to kill the pathogens in our product, in the wastewater raw material. So we do that through a process where we add alkaline material to the wet organic material, and a natural thermal temperature rise and pH rise is created. Those two stresses kill the pathogens. And by the way, when I say pathogens, this COVID virus we're all trying to avoid and eliminate is a pathogen. And by the way, in North America, we're now tracking the number of cases in COVID in the community by looking at the presence of COVID in the wastewater stream. There's extremely high correlation to a high community case count of COVID, and that pathogen being present in the wastewater stream. This process kills COVID, and it kills all pathogens. So we do it through a mixing process, and you can see the picture on the far right. That's our mixer. So literally the alkaline material and the organic material is added, mixed, and it sits for a day while the exothermic reaction does its thing on the pathogens. And then this picture to the left is the second mixing process, because we now have, in the first mixing process, we've created a product that's got a reasonably high pH. We need to bring the pH down because the fields, soils in India are not all that acidic, so they don't need the pH adjustment. So we mix it again with another organic waste material. pH is reduced, and a final product is produced. These are our holding cells where the mixed material sits and the final product sits. The mixed material for the first mixing step is in the left-hand side picture, and the picture on the right is the final product as it comes off the second mixer.
So
and so you can see our alkaline material in the silo on the left, product being shipped out on the bags and the truck, and the product on the right. And we've done a little test field at our production facility, and you can see we're actually showing crop yield increases of 2 to 3 times what would normally be applied, or what you would normally see if the product were not applied.
Yes, Rob. That was. Thank you very much for the presentation, and we could see the impact from your short presentation on the sludge that can get converted into a very valuable and useful material with regards to the agricultural ministry. The presentation, Rob, will be shared by all in this group so that they have more insights, and maybe we could send you more questions. That of course, there are many questions that we may send it to you, and we will have more interactions further. I would like to say thank you for an excellent presentation and time, being a Sunday all the way from Toronto.
Thank you.
Thank you. Thank you very much. Can we move on to the next speaker, please? Yeah. The next speaker for the evening is Dr. Preetham Singh. He is a professor at IIT BHU Ceramic Department and also a founder of Basel Green Energy. You are going to have a very short presentation, Dr. Preetham, or I would say a talk from you, because what you mentioned about your core area of work is getting products like hydrogen, CNG, carbon dioxide, and biotar from agro waste, that is waste to fuel conversion. So this is a very interesting and very appropriate technology to be applied in the present scenario of applying waste. So we would like to quickly hear from you an overview of how your application and research is applied in this sector. Is Dr. Preetham there?
Yeah, he's there.
Yes.
Yeah. Hello.
Yeah, Dr. Preetham, you're on mute.
Yeah, you're on mute.
Unmute yourself, please.
Hello?
Yeah.
Is he come on?
No.
He just messaged me he was ready.
Yeah, he's unmuted now. So Dr. Preetham, can you speak out, please?
Yeah. Could you hear me? Could you hear my question, Dr. Preetham?
Yeah.
Do we have another speaker? Maybe you can move him up.
Yeah.
We have the next
Madhukar.
is Mr. Madhukar Anand.
Dr. Preetham, can you hear us?
Yes. Yes, I can hear you. Can you hear me?
Yeah,
now we can.
We can.
Yeah, we
I can hear you.
Yeah, go ahead, Dr. Preetham.
Okay, thanks. So yes, so I'm going to start now. Just I'm going to share the screen. If it's share screen options are there. So screen.
Or Dr. Preetham, you can just give an overview of how the process you are applying with regards to conversion of bio waste to fuel.
Yes. Yeah, that will be better. I think it may not be able.
A quick verbal presentation would be, please.
Better. Okay. Thanks, Ramurthy for inviting me for the talk. So I'm Dr. Preetham Singh, currently working in IIT BHU in chemical engineering, and we have developed a new process called TAT process. This is called
Hello.
I think we are losing him.
I think he has got
maybe we
muted.
can come back to him after we finish this other next speaker.
Yeah. I think
his connection is very unstable.
Kirti, you could communicate to him to be on standby.
Yeah.
Is Mr. Madhukar Anand on board? Yeah. Hello, Mr. Anand?
Yes. Yeah, sure.
Yeah. Good evening, Mr. Anand.
Sure.
So, a quick introduction on Mr. Madhukar Anand, because he's a very senior person from the power industry. Is an ex-NTPC executive director, and is now executive director of Netra Clean Coal Technology. The power sector has been one of the significant impacting entities with regards to environment pollution, because right from the coal to air pollution to ash slurry to environment impact has always been a very significant part of the power industry. So we would like to hear from Mr. Anand how the power plants have the evaluation has taken place from subcritical to supercritical air-cooled conductors and carbon mitigation and coal gasification, so that the SOx, NOx pollution on the air itself is also controlled, and how power plants are getting to be evolved further in the future, so that the environment impact is minimized with regards to evolution of technology. Mr. Anand.
Thank you, Mr. Shankar Ramurthy. It's a privilege given to me to address such distinguished alumni. और इससे पहले कि मैं अपनी बात शुरू करूं, सबसे पहले तो मैं उस युग पुरुष को सादर नमन करना चाहता था जिसने ऐसे वैश्विक संस्थान की संरचना और संकल्पना करी, जिसके आज इतने यशस्वी विद्यार्थी आज देश में और विश्व में सबका नेतृत्व कर रहे हैं, तो उनको मैं सादर नमन करते हुए I'll bring in my presentation. The topic of my presentation today that was given to me was about clean coal technologies. So I would like to just briefly glance through what are the major things that we have been able to do in clean coal technologies. As you know that India was a power deficient country sometimes back, but due to the initiatives taken, we have moved far ahead. And if you see that what has been the pathway now we are talking about green energy. So what has been the pathway? So if we see that for all our new plants, we are going for supercritical or advanced ultra supercritical technologies. And mind you that each 1% of improvement in efficiency results in CO2 emission reduction by approximately 2.5%. And apart from that, it is inevitable that we move towards green energy. And so we are going into for renewable energy also in a big way. Now, fossil fuels, as all of you know, that it has got a lot of disadvantages. You have that CO2 emissions, you have SOx emissions, NOx emissions. So emission control becomes a very important thing. And then we have to definitely take steps to go for energy efficiency improvements. And as we know that in the COP summit that happened, that India has determined that they will reduce their emissions by around 35 to 40%, and we are on way to achieve that. What are the basically, although whatever we may say, howsoever renewable may go to, coal is going to remain the mainstay of energy for India till 2050 at least. Because what happens is that with renewable, this solar storage system, battery energy storage system, or hydro pumped storage systems, they are all under evolutionary phase, and it will take time to come. So, as we know that what are the major things that we will need to concentrate is the carbon dioxide, greenhouse gas emissions. Then there will, because of the influx of renewable, we will have to gear up our plants for flexible operations. Then there will be cost reduction. We will have to go so that the power becomes affordable, and NOx and SOx emissions also we have to control. See, this was basically what I told you, that we have reduced the emission intensity of its GDP by 35%. And the share of non-fuel, fossil fuel based electricity, that is basically renewables, to 40% by 2030. And we are all well on our way to achieve it. Now, for this, what planning we have done, we have done conservative planning for up to 2032, that in stages, what are the things? So first of all, we have to decarbonize our economy. So for decarbonization of economy, what we have to do, that we will have to reduce the CO2 emissions intensity very much. So by 2013, from the present 2012 levels, we'll be reducing it by 17%. Renewable capacity, we are going to be of our old portfolio, which is presently around 65,000 megawatt. So that is going to be around 30% at that period of time. Then we will have to have super and ultra supercritical only. We'll be gradually phasing out all these subcritical and non-reheat units. Then air emissions, of course, we will be reducing sulfur dioxide, the reduction in specific NOx emissions, reduction of particulate matter. You know that it was approximately 100 ppm. So now we are targeting 30 ppm, and we are still hoping to go down further. Regarding water availability, see, fuel power plants are basically for all industrial water consumption. The major water consumption is by power plants. So what innovative technologies we are going to reduce that water consumption? So we have taken steps, but previously it used to be around 4 to 5 meter cube per hour per megawatt. So now Environmental Ministry, in consultation with us, we have reduced it drastically to 3 meter cube per hour per megawatt. And we hope to do even better, because as you are aware that we are dispensing away with cooling towers, and we are going for air-cooled condensers. Then we are also going to have wastewater recycling. We are doing it almost 100% now. And of course, we are taking up biodiversity projects, tree plantations, etc. That is in addition. Ash utilization. Ash is one of the major byproducts that we create during power generation. And you'll be happy to know that previously it was considered as a waste, but now it is being dedicated as a resource. And there are parties lining up to purchase that fly ash. And at around 15 of plants, we have achieved approximately 100% of ash utilization. I'll come to later on about how do we do that. Recycling of waste, we are doing it approximately 100% of cycling in our waste. And biomass firing, in the last presentation, we were talking about turning biomass into useful product, fertilizers, etc. But as you know that in Delhi or NCR region, during this period, there is a lot of pellet firing of biomass. Agri residue waste is fired, and parali, because of parali burning, the atmosphere becomes very, very energetic. The AQI level goes up to 500 and 1000 levels. So we have initiated steps to convert that biomass into pellets and then fire it in our furnaces. So what is going to the future thing is the emission management and basically water use management. So these are the basic consideration on which we are based our power plant. So if you see that what our journey is going to be, if we say in 2032, what are we going to do? So efficiency levels, what we are approximately at around 40% now, we are going to around 50%. Similarly, reduction in carbon footprints, we'll be reducing it by 30%. Land area, which was used to be approximately 1 acre per megawatt, we have come down to levels of approximately 0.35 acre per megawatt, and further we propose to go to 0.25 megawatt. And water consumption, already I told you that we are going to reduce it even below 2 meter cube per hour per megawatt. And auxiliary power consumption, of course, we are going to reduce. So what an ideal plant would look like: that minimum land, renewable integration, zero discharge, 100% reliability, higher efficiency, low water usage, and approximately 50 years life of the project. And so these are also the innovators. These are also the basically innovators that give us direction in which area the future path of the energy sector is going to be. So if we see the national and societal obligations, so it will be CO2 mitigation. For business concerns, it will be water. For blue sky prospects, we'll be reducing SOx, NOx, and we'll be converting CO2 not as a waste product or sequestration of CO2, but we'll be converting into useful products. Similarly, for ash, we'll be converting into number of products. Of course, we are doing desalination and wastewater. And you'll be happy to know that even at Varanasi, at Karsara, there's a municipal solid waste plant which has been taken over by NTPC, and we have established a 24 TPD per day plant where we are generating around 200 kilowatt of power based on municipal solid waste. Of course, biomass based solid gasifier already present, but we have first time demonstrated that on municipal solid waste also we can run it. So this has been our journey. If you see, I'll give this presentation for you to go to in detail. But basically, our journey has been that now we will go for big wave for solar, reduction in CO2 footprint, then energy storage systems, we will have to progress. Now, what are the new environmental norms that have come? As you know that previously there were no norms. We were doing 600,000 milligram per normal meter cube for SO2, NOx. SPM was also 150, 300. So now all these have been drastically cut. It has SOx and NOx has come down to 100 milligram per normal meter cube. SPM has come down to 30. And mercury, of course, it has come down to 0.03, but mercury has not been such a problem with our coals because we are already having low mercury coals. Consumptive water requirement, I already told that it is coming down to 3 meter cube per hour. And with advent of air-cooled condensers, we will be further reducing it. All our plants are bound to be zero liquid discharge. And we are, for all our plants where there is a sewage treated plant, any city, if there is a sewage treated plant like our Moda plant or Sholapur plant, which are the municipal boundaries of Nagpur or Sholapur, it is mandatory for us to use sewage water for our process requirements. Now for ash production was one of the biggest challenge. So ash production, if we see, it was gradually increasing, and right now it is around 235 to 240 million tons. So this is what Professor Shankar Murthy was asking for about how the efficiency improvements we have undergone through. So previously our focus was on emissions control, then where we took stack height norms, ESP design customization, then with NOx control, mercury control, flue gas desulfurization. Then for efficiency enhancements, that we enhance the unit parameters. If you see the modified Rankine cycles, so the parameters we have enhanced considerably. Now that plant that we are going to set up advanced ultra supercritical at CPAT will be having a parameters of 310 bar and 710 mainstream temperature and 720 reheat temperature, which is one of the best, finest unit parameters in the world. And you'll be happy to know that India is in the leadership position for this. Then supercritical technology, then of course I said about IGCC, and then of course renewables. So this has been journey. If you see that from 1900 onwards, we were lagging behind where the but with the advent of BHL and NTPC in 1917 and 80s, we have caught up with the world, and now we are in a position of leadership regarding advanced ultra supercritical technology. So this is how the efficiency curve has improved. If you see that the subcritical efficiencies used to be around 37.9%, and now we are operating at around 42.2% and 46%. Of course, turbine cycle heat rate efficiency will be more than 50%. And the carbon reduction that we have been able to achieve, will be able to achieve, for that would be around 17%. And you'll be knowing that for each megawatt of energy, approximately 0.94, 0.95 is used. And just to give you a brief overview, that as far as per GDP consumption, India is one of the lowest, but in absolute terms, yes, of course, so we have a social responsibility to reduce it. No, but there is a very much influx about carbon dioxide, but when we talk about greenhouse gases, carbon dioxide is not the only gas. If we take the global warming potential equivalent, so carbon dioxide, if it has got a 1 potential, so if you see that methane, nitrous oxide, perfluorocarbon, hydrofluorocarbon, sulfur hexafluoride, nitrogen trifluoride, they are in multiples of hundreds and thousands of times of carbon dioxide. So we have to address these issues also. So if we do not address this carbon issue, what our carbon dioxide concentration, which is around 400 now, will go to by 1000. And the temperature increase will be around in the range of 2 to 5 degrees centigrade. So it is imperative for us to go in for superior technologies. And this is the two paths that we have as a power sector consciously explored. One was operating the parameters, developing new technologies, new materials for sustaining of high temperatures like Inconel, P92, etc. that we are developing. And second was the schematic direction like IGCC, etc. and gas turbine path. So Indian, I just give you a brief overview of Indian Advanced Ultra Supercritical program. So it is a collaboration between NTPC, BHL and IGCAR, and where we are aiming for 18% reduction in carbon dioxide and 1,500 crores, which involved the first phase. All research has been completed. Now we are into development of boilers with advanced high temperature materials, design and development of indigenous development of turbine blades and metallurgy with Inconel materials. Also, we are doing Mishra Dhatu Nigam is developing that for us, and specific welding joints, etc. we have been able successfully to develop up. So we are moving well ahead, and we are by 2022, we are trying to set up first demonstration plant at Sipat, which will be of 800 megawatt capacity. And coal has an inherent advantage is that if we take care of efficiency, carbon emissions, etc., it has, the prices are less volatile and you are assured of a assured power supply, which is not the case with renewables. So renewables, if you see now it is around 88,000 megawatt, but then it comes with a host of problems that all your existing plants will undergo cycling, then balancing power, spinning reserves, then you will have to create separate open access for that. So those transmission costs, etc. So their cost is not less. Plus the recycling cost, the manufacturing cost of solar panels, etc. also have to be kept in mind. Batteries, of course, if they come, they will definitely become viable. So there are certain things that batteries, flywheel, pump, hydro, to certain capacities they have matured, but they are super capacitors, flow batteries, compressed air, they are under development. So these are a must for development for utilization of solar and wind energy on a commercial scale on a regular basis. So this is what IGCC I told about, that is integrated gasification, combined cycle power plants. And we had done a study for 100 megawatt, and we proposed to set it up at Dadri, but it was somehow delayed. But we have all the studies completed. And this definitely gives an improvement in efficiency, where we directly gasify coal and fire into the steam turbines, gas turbines, sorry. So this will give you advances. So I've given, there are different processes where sometimes gas turbine is replaced with solid oxide fuel cells. So because of paucity of time, I'm not going into very details of these technologies. Then, of course, circulating fluidized-based combustion boilers are also there. So their efficiencies are also quite high. And because of low temperature combustion, the generation of SOx and NOx is also less. Then carbon sequestration, of course, is there. But carbon sequestration has got a heavy energy penalty. And if we take carbon sequestration into account, the cycle efficiency or the plant efficiency reduces by approximately 30%. So what opportunities it affords us? So carbon dioxide is something that is available free of cost in our flue gases. So we have taken up a project that how to, rather than sequestrating it, why not use it? So we have developed technology for capturing of this carbon dioxide, and then using it, reacting it with hydrogen, developing indigenous reactors and catalysts to produce basically methanol. And I'm sure that India is heading towards methanol economy, and the price that we are basically from the feasibility studies, it will be much lower than the market prices of methanol that is available. And we can further convert it into dimethyl ether, which can 100% replace diesel, etc. Similarly, by capturing by bioalgae methods, we can do a lot of nutrients and omega acids, etc. we can also create. So these are also the things. There are challenges, of course, in this. Green hydrogen, of course, if you convert, get hydrogen from the basically steam formation process, which is the normal practice in this practice. So it is very energy intensive, or by electrolysis, you get, it is very energy intensive. So we are targeting for getting it through green energy, through solar energy, and we have set up, and we are very hopeful that we'll be able to set up, and we are setting up a center at Ladakh, where we'll be driving EV buses from hydrogen, and that hydrogen will be generated through green energy, solar energy. So this is all what we have been doing. And regarding the SOx, NOx, we have, for all our plants, NTPC is at the front line. We have developed technologies, and we have deployed it at a vast scale, and we will be the first to achieve it in the country. Our Dadri and Jhajjar plant, Vindhyachal, Bongaigaon are already on the achieved it or on the verge of achieving it. So there are a lot of technologies in FGDs. So, but NOx has becoming a bit problematic because of the high ash Indian content, because the catalyst, etc., that we have done pilot studies, they are getting poisoned. So NOx reduction of 100 milligram per normal meter cube that has been envisaged by MOF does not seem to be possible, and ministry has taken cognizance of that, and they will be reducing it, increasing it to 350, which we can achieve by combustion modification. So water, of course, we said that we are reducing it. And how do we use? We reduce, reuse, and recycle. Mr. Shankar, you can always tell me if I am running out of time.
I think we have got a real overview, Mr. Anand. That was an excellent presentation in the time slot.
Just take 2 minutes of time. That in ash, of course, we know that a lot of ash is there. And what we have been doing, apart from the lot of brick concretes that we discussed in the morning sessions, but what we have developed is something very good, that geopolymer concrete roads, where we can use ash and replace totally cement. We have developed lightweight aggregates, where of course 80 to 90% of aggregates can be replaced by fly ash, and it will be a huge benefit for the country. In the picture you show that at Ramagundam plant, we have converted a road into M40 strength road. And similarly, we have used bottom ash as partial replacement of sand. Sand is becoming a resource commodity, so we have been able to do that. We have developed geopolymer pipes. We have been able to do geo-tetra pots. So all these things we have developed. So a lot of things are there. I would request, if I get opportunity, a lot of developments and innovations that have taken place. We can get into that. Thanks a lot.
Perfect. Thank you so much, Mr. Anand. Basically, we will share your presentation among all the participants. Whereas the audience is comprising a lot of academic students and the budding engineers, especially on the power plant side. So if there is any question, what we will do is we would like to consolidate and send it to you, and then we'll have this forum group, and then we would get them those answers from your, very, very extreme experience in operating a power plant. And we gave us such an insight into what is a power sector and power plant. We have been talking of water the whole day, right from morning. And it has been a welcome change to talk about the power sector and how the NTPC, a premier organization which has been impactful in the whole power sector in India. And we have a lot to learn from you, Mr. Anand. I would say thank you very much, and we look forward to more connects with you.
I thank you for the opportunity given, but I think a lot of things are there to share.
Yes.
And future opportunities I look forward to. Thank you. Thank you.
Thank you very much. Thank you. We can have a quick chat with Dr. Preetham. Are you there?
Yes. I'm there. I'm audible.
Yeah, please. You're audible. Please go ahead as an overview. Yeah, please.
I'm just going to. We have developed at IIT BHU and then translated into the BL green energy. So I have made a technology, our team has made a technology that convert a biomass into 4% into the hydrogen, around 20% into the CNG, and 30% into the biocoal. See, if we have to. So what we are doing with the CNG as a transition fuel. So if we say petroleum is a fuel which is a telephonic stage of the fuel, and CNG is a transition fuel, and we world has to move towards the high energy fuel, and we have to move towards the hydrogen. So the key goal to achieve is how to produce hydrogen by clean energy, means using the biomasses. So if you see the plenty of the biomasses available, and our major focus in the world is to convert them into bioethanol, biomethanol, and other kind of sources. However, a biomass generally contains 6.7 to 7.1% hydrogen in its kitty. If we convert them into the hydrogen, then it can be converted into the very, very valuable resources. And that's what we have been able to develop here at IIT BHU, and then translated into the international model. I mean, say to the industrial scale. So what we have done, we have developed a system similar to the this fractionization process occurring inside the Earth crust. As we know that Earth crust, the masses have been converted into.
Can you go a little away from the mic? Maybe you'll be more audible clearly. Little away from
yeah, there is a lot of feedback otherwise.
Okay.
Yeah.
Yes.
Yeah,
okay. So now it is fine.
Yeah, please go ahead.
If voice is fine, okay. So then what we have done, see, consider the gasification and the pyrolysis process existing in the world, where they have the masses have been utilized in the partial oxygen, the combustion happens, and most of the burning part in the form of CNG is utilized, and much of the high ash content is produced through the any gasification process existing in the world. And they able to convert hardly around 3% biomass into the hydrogen and around 20% mass into the carbon monoxide. If you go to the energy percentage wise, 21% of the CO is equivalent to almost 3.5% of methane. So the existing gasification technology convert biomass into almost 2% of hydrogen to 3% of the methane. And that is happening because the biomass is getting burned. What we have done fractionization technology as happening inside the Earth crust, where biomass is segregated and under control, the masses has been converted to tar or biofuels in fossil fuels in terms of petroleum. When the time lag means more, then it has been converted into the natural gas as in the Russian peninsula. And when the gases and the liquid have been overdue, and then coal have been left out in the Indian Peninsula, Australia, or the South African area. So if you see the timeline, and if that's what we have mimicked, so we have mimicked a temperature and pressure control process where biomass is first converted into the biotar, and then the process continues and it has been converted to the CO2 removal. So the first, the carbon-oxygen bond of the biomass has been broken, and we have taken out the carbon dioxide out. And then further the mechanization starts and the reactors, and then at the end, when the it will convert into the hydrogen. So what we have achieved in our biomass in 4% of direct hydrogen, around 18% of direct CNG, and the left out is 30% of the biocoal. And if we go natural balance, then we get around 44% of the carbon dioxide. So the every means of the biomass has been converted, and this has not been done only on the lab scale. We have converted our feasibility from kg of biomass in single operation of 36 hours. There 25 kilo of the 5 kilowatt of the power supply needed 36 hours, and in the we get around using 1500 kg of biomass, around 60 kg of hydrogen, which is used in terms of the economic value. Then we get around 100 kg of the CNG and around 200 kg of has the huge feasibility in converting the biomass, and it is not limited to use of the single channel biomass. Means neither it is the only parami waste, neither it's in our carbon waste. We can use any kind of solid waste which has a carbon, hydrogen, and oxygen or any carbonaceous material. Even plastics, tires, single-use plastics can be utilized in our reactors. And this has been commercialized into the industrial scale. So now we have started producing and supplying biohydrogen through NTPC power plants, and they are using our hydrogen as a coolant. So this is our establishment, and we are looking from the future ventures where we are going to increase our facility from a plant-to-plant basis, and we can go ahead with the complete green fuel solutions. Because from any existing technology which converts biomass into fuel into around 5% conversion, we are reaching up to total biomass into 50% conversion. So I will be more happy with it will be the interactive session with the question, because some problem with my presentation. So
yes, Dr. Pritham, that was a very good overview in the short time that was available. Yes, there's a.
Yes.
I congratulate you on the subject that you have researched on, and then made a impactful system to convert the agro waste, especially on a segregated waste of good calorific value of more than 2000 or 2500.
Yes. Yes.
So that the waste has got that potential energy to get converted to various products. So so we might take a question or from the audience, or maybe we will definitely circulate your presentation when you send it to us, to all the participants for more interactive sessions and future discussions on this sector, because it's a huge.
In the process, yes. So one point I wish to add further, especially the biocoal we produce, it is a graphitic coal. So that is another very important aspect of this research. When we use the leaves and the scrap wood, especially, they have the porous channels, so they have completely smokeless biocoal, which have a GCV greater than 8,000 calories per gram. So this is huge, and in terms of ash content, less than 3% ash biocoal. So that is something very special in the whole process. Even though it is very special for the hydrogen, because it is the highest conversion possible till now achieved. But not only that, in terms of coal also very which can be utilized as a green coal and high energy coal. It's almost to the pet coal.
Okay. Very informative on the future conversion of waste to fuel. It's a deep dive technology that we need to really understand, and maybe we can connect with you in future to get this.
Why Shankar? Why did he take graphite coal of all the coals?
That because of the calorific value. That's what he mentioned.
No, I have not read that. I produce graphite coal. See, from biomass we produce graphite coal. The coal comes out as graphite. It's not that we use graphite coal. The output is graphite coal.
Okay. academic.
Yeah.
Good academic.
Thank you, Dr. Preet. We would now conclude this session of discussions of various technology for scientists, entrepreneurs, and inventors. It has been a very informative session, and particularly a welcome change from the water, wastewater to Madhukar Anand's presentation on power plant. That has been a very revealing and very informative session. So thank you, gentlemen, for all the presentations, and I will now hand over to Kirti and the rest of the team to carry on the formalities.
Thank you so much.
Thanks, Pradhamurthy. Thanks.
Thank you so much, Mr. Shankar. I now invite Mr. Sanjeev Nikor, Vice President AIBA, for vote of thanks.
It's been a, thank you, Kirti. It's been an awesome day, starting from morning, 9:45 to 10. This time we wanted to give a lot more technology. To a large extent, I think we have succeeded in bringing a range of speakers, from talking about accelerators to digital technology to what Dr. Preetam Singh talked about. And then, I would like to thank all the speakers since morning, evening. I can't recount every one of them. It will take too much time. But suffices to say that we covered a very broad spectrum, although there was a bit of more focus on the water side. Certainly, in the next event that we'll hold maybe in a few months' time, we will come back to air. But I think we did get a very good glimpse of various new technologies on the horizon from across the globe. And I must thank, Rakesh Kumar Khare, I must thank Shankar, Vaibhav Dayal, all these people who helped us to bring the speakers on this platform. I must thank the entire organizing team, which worked very hard to make this happen. I would like to thank all the attendees and the participants who listened very patiently to some very complex technology from various speakers, despite some technical small glitches we may have had. I'd like to thank the student body, the SAIC, the ECEL, who really contributed, worked very hard. I would like to thank the Executive Council of AIBA, IBGA, and so many people came together to make this complex event come alive. Was a bit disappointed at the slightly lower attendance that we had this time compared to some of our other events. But I'm sure maybe there has been some probably lacunae in us in terms of socializing it. So I'll take that chin up. It's okay. It's an important lesson to us, but we will make up by distributing the material to a wide range of people. And I think we'll reach out what we may not have reached out in live audience. We'll reach out through distributing the material in a proper way. So I make that commitment to everybody because it's very high quality material. We have been able to network with a lot of people. For example, NIRI was interested in collaboration with IIT BHU. Shell have told us that they are willing to do a hackathon with us. So many opportunities to collaborate and network. So this event will have a major impact, and we want to set up a forum on environment. More power to IIT BHU, more power to our alma mater, more power to intellectual thought. And I think this event would have made that impact. I would like to thank everyone. And if I missed anyone, please excuse me, please pardon me. It's been, hectic last 10, 15 days in getting this together. And thank you so much. All the students, Vaibhav and his team, Dirghai and his team. And so I would like to conclude here. And thanks a lot. Somehow we have been able to make it only 10 minutes later than we had decided.
And Sanjeev ji, thanks a ton for leading the effort. I think you've done a humongous amount of effort. Thank you. Yes, I second that. I second that. Well done, Sanjeev.
Yes, I fully agree. Sanjeev has been a great inspiration.
And we'll have the material distributed.
Yes.
I think kudos is due to all the EC members and all the organizers who have participated. I think for the last 6 months, we have been seeing excellent outcome in terms of program and effort. Phenomenal, I must say.
Yes, Debashish, I fully agree and second that. Sanjeev has been driving us daily 9:30 calls and driving us.
So now the serious